Chapter 4.6, it's called Formalizing Relations and Functions. I don't want the name to scare you away too much. Basically, it's just this. To determine whether a relation is a function, which isn't as hard as you may think, and to find the domain and range. So I know those are probably two new words to you, but domain is essentially your input and the range is your output. So I'd like you to put this part in your notes. A relation is just a pairing of numbers. One of those sets or one of those pairs is called the domain, and the numbers in the other set are called the range. Oftentimes we look at them as an x and a y, and in that case the domain is your x's and the range is your y's. Okay, so again, think of domain and range as your input and your output. The range would be your dependent variable, and the domain would be your independent, which is also would be a good idea to put that in your notes as well. So what they just want you to do for this section is identify the domain and range of each relation and represent the relation with a mapping diagram. So the mapping diagram is just done like this. You just write your domain and your range, and you put the numbers in the column. So the first numbers are your domain, your independent variables, -2. Next one is 0, 4, and 5. And then your ranges, they have to go together, 0.5, 2.5, 6.5, and I'm sorry, I didn't mean they had to go together like this. You just list them. And 2.5, except that 2.5 is already listed. Okay? Once you do that, you draw lines to match them up. So -2 went with 0.5, 0 went with 2.5, 4 went with 6.5, and 5 also went with 2.5. The next question is the relation a function? And to answer that question by looking at this mapping diagram, you say, are there more than 2 lines going from any number in the domain? Okay? Each domain value can only be mapped or have a line to one range value. Okay? So again, write that in your notes. Each domain value can only have one line going to a range value in order to be a function. So now let's do this one. We have our domain, we have our range. The domain is 6, 4, 6, 5. That's it. Our ranges are 5. Oh, sorry. 6. I'm going to write that again. 6, 4. 6 is already there, and 5. Our range is 5, 3, 4, and 8. And then again, you just match up the numbers. So 6 went with 5, 4 went with 3, 6 went with 4, 5 went with 8. So this one was yes, it is a function. And this one is not a function. The reason is the domain, one of the values in the domain, has more than one line, meaning it matches up with more than one value in the range. And that's the way you can tell. Over here, it's okay if a range value has more than one line coming into it, but the domain cannot have more than one going out of it. Okay? Another way to decide that is if the relation, if it passes the vertical line test. And the way that you do your vertical line test is if this was our function, and let's say it was kind of a curvy line, what you do is you take your pencil and you lay it down vertically, and you just slide it along. Okay, so this is, I'm going to act like this is the pencil. So if you just slid it along different points in this graph, is there anywhere when your pencil or a vertical line would intersect more than one point on the graph? And the answer is no. There's nowhere where it hits more than one. Okay? So this one is yes. It passes the vertical line test. But then if we had something like this where it was an absolute value, it was going this way, and you started doing the vertical line test, here you have a vertical line that intersects the graph in more than one spot. And because of that, this does not pass the vertical line test. So this one is a function, and this one is not a function. Okay? Is a relation a function? Use the vertical line test. So we're going to do this real quick. So -4, 2, there's a point. -3, 1, point. 0, -2, point. -4, -1, 1, 2, and that's everything. So that is, okay. Now, if we were doing this and we had to draw a line, it'd be kind of a curvy line, but what you do again is vertical line test. If you just move your pencil along vertically, is there anywhere it intersects more than once? And the answer is yes, right here, and right here it has 2 points that it intersects. So, is that function, does it pass the vertical line test? No, it does not. We're not going to worry about part B right there. If you were curious about that one, this is what it looks like. Okay, so it does pass the vertical line test. Last thing is function notation. Function notation is pretty easy. It basically just takes your equation and it replaces the dependent variable, which in this case is the y, with f of x. What the f represents is that's like naming the function. So if we say, hey, this is your function, we're going to call that function f. And then the reason that they have x in parentheses is because they want to make sure that you know that this value here depends on the x value, the independent variable. Okay? You can use other letters besides f. You can use g, you can use h. But this would be a good idea to write all of this down in your notes. It's just a different way of writing. The way that we use this is very much the same way you would if it was just a normal equation. Your function is w of x equals 250 times x, where it represents the number of words. So instead of w, they use w of x. You can read in x minutes. How many words can you read in 8 minutes? So what you do is you write this, meaning w of 8 would equal 250 times 8. So this is, it's like saying this. This is our function, w equals 250x. What would the function with 8 in it be? And it's 250 times 8, which w of 8 comes out to be 2,000 words. And those are the things that you need to know for this new section. If you have any questions, please write them down and let me know.